everyone, and welcome back to our course on modern web development. Today we're starting an exciting new module on generative AI. In this lesson in particular, we'll dive into the world of artificial intelligence and machine learning, laying the groundwork for understanding how AI can enhance our applications and make our lives easier. So some lesson objectives for these lessons are that we're going to understand AI and machine learning concepts. We're going to differentiate between AI, machine learning, and deep learning, learn about supervised and unsupervised learning, explore common machine learning algorithms, and we're going to discover and talk about generative AI and GPT models that we're going to mostly work with later in the course. So, what is AI? Artificial intelligence, or shortly AI, refers to the simulation of human intelligence processes by machines, especially computer systems. So, to make it simpler, artificial intelligence is just trying to copy how we think, so human intelligence. And these processes include learning, so acquiring information and rules for using the information, reasoning, using rules to reach approximate or definite conclusions, and self-correction. So, as you know, AI has become an integral part of our daily lives. From voice assistants like Alexa or Siri, to recommendation systems on Netflix and Amazon, and yes, those are also considered machine learning and AI algorithms. AI is definitely shaping how we interact with technology today. And you've probably heard of AI from recent boom of ChatGPT, which happened approximately 2 years ago, and now it is completely going crazy with AI is all over the place. So yeah, it's become definitely very important in our daily lives. So some of its real-world applications are that it is very crucial in NLP, which stands for Natural Language Processing. So language translation services, chatbots, and voice assistants like Alexa, Siri, even ChatGPT, because it uses NLP to give us response and just chat with humans. Also, it is used for computer vision, such as facial recognition, self-driving cars, such as Tesla, and medical image analysis. Also, it is used widely in recommendation systems, such as TikTok, Instagram feed, so personalized content on social media, e-commerce product suggestions, and more. And also, it is widely used in healthcare, so predictive diagnostics, personalized treatment plans, etc. And AI is not just about robots or futuristic technologies. It's about making machines smarter to solve complex problems and improve efficiency overall. Now we're going to switch to basics of machine learning. So let's focus on that now. Essentially, machine learning is a field of study that gives computers the ability to learn from data without being explicitly programmed. Instead of writing code to solve a problem directly, we give data to a generic algorithm, and the algorithm builds its own logic based on the data. So basically what we do as people, we just give a bunch of data to a machine, and it learns on its own from the past experience. And the more data they see, the better they get at guessing or figuring things out. So they become smarter and smarter with more data. But it's important to avoid bias, and we're going to cover this later. So machine learning algorithms use statistical techniques to enable machines to improve at tasks with experience, and the more data the algorithm uses, the better they become at making predictions or decisions. So why is machine learning important? So first of all, it is very important for automation. So automate tasks that are difficult or impractical to program explicitly. Also make sense of large volumes of data to find patterns and insights in the large data sets or just bunch of data. And also systems can adapt to new scenarios based on the new data. And machine learning is the driving force behind many AI applications, from spam filtering in our Gmail to predictive analytics. And some types of machine learning. So the first one is supervised learning. In supervised learning, the algorithm learns from labeled training data. That means the data is already tagged with the correct answer. So, for example, my phone, it will be already tagged with the name, like the label that it's my iPhone. And yeah, we basically have already labeled data. And how it works, essentially the algorithm makes predictions based on the input data and adjusts itself based on the mistakes in its predictions. Some examples are classification, so determining if an email is spam or no, and also regression, so predicting housing prices based on features like size and location. The next type is unsupervised learning. So its definition is that in unsupervised learning, the algorithm works with unlabeled data and tries to find hidden patterns or other structures within that unlabeled data. And how it works is that algorithm analyzes the data to identify different patterns or groupings without any prior training. And some examples involve clustering, so grouping customers based on purchasing behavior, and also it is suitable for anomaly detection, so identifying and classifying unusual credit card transactions. And the third and the last type is reinforcement learning. So where I'm gonna briefly mention it. So the definition is that reinforcement learning is about making decisions sequentially, where the output depends on the state of the current input and the action of the algorithm. And the algorithm learns by interacting with an environment and receiving rewards or penalties. And some examples are AI agents learning to play games like chess or Go, and it is used in robotics, so teaching robots to navigate environments. And understanding those types helps us choose the right approach for a given problem. And now we're going to briefly cover common machine learning algorithms. You don't have to study them in depth unless you want to go straight into machine learning and you want to pursue that field in depth. But now we're just going to cover them briefly. So the first one is linear regression. Basically, its purpose is to predict a continuous output variable based on one or more input variables, and predicting sales based on advertising spend is one of the examples. The next one is logistic regression. So its purpose is to use for binary classification problems, such as determining whether a transaction is fraudulent or not. The third one is decision trees, which is very popular. So its purpose to model decisions and their possible consequences in a tree-like structure, and it's widely used in customer segmentation. The fourth one is vector machines, shortly CVM, and its purpose to find the optimal boundary between possible outputs, and they're widely used in image classification. The fifth one is k-means clustering, so partition data into k distinct clusters based on feature similarity, and its use case is primarily in market segmentation. The sixth one is neural networks, which is also very popular and you might heard of it. So its purpose to model complex patterns and prediction problems, and it basically copies how neurons work in our brain. And some use cases are speech recognition and image recognition. And each algorithm has its strengths and is suitable for different types of problems. So now I'm going to introduce you to generative AI. So let's focus on that for now. Generative AI refers to algorithms that can generate new content such as text, images, audio that is similar to the data they were trained on. Unlike traditional AI models that predict or classify input data, generative models create new data instances. So that's what ChatGPT or other LLMs such as Claude, Llama are all about. So how does generative AI differ from other AI? So generative versus discriminative models. So discriminative models focus on predicting labels given input data, such as is this email spam or no, and generative models focus on generating new data that resembles the training data. For example, composing music, writing text. So that's why when we ask ChatGPT to create a new poem or compose music, it actually generates some text for us, a new poem or music from already trained data sets. And some applications of generative AI are text generation, so writing articles, composing emails, chatbot conversation. It is also useful for image generation, so creating realistic images or art or deepfakes, or audio generation, synthesizing speech and creating music. And generative AI opens up a lot of possibilities for creativity and automation in ways that were previously not possible. That's why ChatGPT created such a chaos in AI industry, and now everyone is using it because basically it does a lot of manual work that humans used to do by themselves. So some examples of generative AI models. The first one is GPT, so which stands for Generative Pre-trained Transformer models. It is developed by OpenAI, not surprised, and its purpose to generate human-like text based on input prompts. And some features include pre-training, trained on vast amounts of internet text data. So basically, it scraped all the internet, and its capabilities include that it can continue a text, answer questions, translate languages, summarize content, and make predictions. And some applications involve content creation, code generation, and virtual assistants. The second type is called GNN, which stands for Generative Adversarial Networks. And how it works is basically consists of two neural networks, a generator and a discriminator, competing against each other. So I put like a workflow, a picture, visual picture on the presentation, so you can see, I think, if my camera is not interfering with the picture. So yeah, its purpose to generate realistic images or data, and some applications involve image synthesis, enhancing image resolution, and generating art. And the third one is VAE, which stands for Variational Autoencoders, and its purpose to generate new data points by learning the probability distribution of the input data. And some applications include data compression, anomaly detection, or generating new data samples. And some real-world examples include deep art, which transforms photos into artworks using styles of famous painters, and the famous model, also from OpenAI, which is called DALL-E, which generates images from textual descriptions. Generative AI models like GPT have completely revolutionized how we approach content creation and automation. So yeah, we briefly went over examples of generative AI models, and pretty much you just have to remember about GPT models, so developed by OpenAI, so you can read more about GPT models on their website, because we're primarily going to target those models and work with OpenAI and API in our future lessons. And so yeah, here are some real-world generative AI applications. So as I mentioned earlier, it's text generation, code generation, chatbot conversations, deep art, and DALL-E. So this picture on the right was generated by DALL-E, so that's how you can use it to generate different art pieces. So I basically asked ChatGPT to generate a random picture, and it gave me a forest. So yeah, as a conclusion, today we've covered a lot of ground for AI and machine learning. So we understood what AI is and its real-world applications. We also talked about machine learning, so learning about supervised, unsupervised, and reinforcement learning, and common algorithms. Also, we went over generative AI, which we're gonna work mostly with. So we explored how generative models work and examples of GPT. And as we move forward, we'll start integrating generative AI into our own AI-powered applications. And in the next lesson, we're gonna actually explore OpenAI's API and see how we can use GPT models to generate text. So feel free to revisit this lesson to reinforce and improve your understanding of AI. And if you have any questions, don't hesitate to ask and reach out to my team using social media. And by the way, if you want to dive deeper into AI, you can read a bunch of papers or books, or just watch different tutorials on YouTube, or go straight to OpenAI's website, because it has like a research department where you can just read a bunch of research papers they're making frequently and learn more about AI and how it's shaping our modern world. So once again, thank you for this lesson and thank you for your participation, and see you in the next one. Happy hacking!